Hello? Can you hear me? Great, great. Thank you, Shirley. As she mentioned, my name is Steven Beata. I'll be joined on the stage later on by Matt Campbell from D2L. So why are we here? So if you're in this session, chances are you're interested in cloud. More than likely, you have data. I still haven't met anyone without data. And you're looking at how can you move that data into the cloud. There are many different ways of doing it. But what we're going to talk about today is how do you take your on-prem data and make it usable to either leverage it with your applications, perhaps back it into the cloud because either you're running out of room or you just find it's a lower cost or potentially even a DR solution perhaps. And then what we're seeing more and more, people are starting to leverage a wider array of AWS services to get value of that data, right? So basically, a lot of people are starting to look at how can I run data analytics on data that was sitting on-prem for potentially years. It was costing us money, but we weren't able to get any kind of insightful information out of it. So that's one of the later use cases we're seeing customers use it for. But before we start talking about hybrid storage and how do you extend your storage from on-prem to the cloud, we'll quickly talk about storage in general in AWS. Much like in other areas, there's 3 different types of storage we usually look at when we talk about AWS. You have your block storage, so your ones and zeros. You have your file storage. So traditionally, there's a file system laid on top of that ones and zeros. And then you have object storage. Object storage is actually an interesting case because it was one of the first services that AWS offered their customers back as far back as 2006. In 2013, I was at one of those analyst conferences, and it was an interesting talk by a well-renowned storage guy who said, object storage is the best solution for the problem we haven't found yet, which I found kind of funny at that time. What's interesting about that is that although they were unable to find it, our customers have. So today in AWS, we have in S3 service specifically, we're running trillions of objects at any point in time. Also, often we will reach performance capabilities of millions of requests on those same objects. So not only are our customers finding a purpose of object storage of storing data, but they're also leveraging that data for their business purposes. So why do people choose S3? So as you can tell, it's secure, it's durable. So from a durability perspective, it's designed for 11 nines. So if you have something like 10 million objects in S3, you're bound to lose one in 10,000 years, something like that. And it's very cost effective. S3 has actually a family of different offerings, which I'll go into in a minute. And depending on your use case, you will choose one of these landing zones. And then based on your policies, you're able to move data from one or higher tier storage to the lower. We also have the Amazon Glacier product, which is designed basically to allow you to, how do you archive your data into the cloud? And not only how do you archive it and forget it, but how do you archive it and actually make use of it if needed? Although we don't have time in this session, there are really good sessions to look on YouTube for Glacier on how do you query that data to get insights out of what you were considering to be data that you set and forget. Besides being secure and durable, so it has the same 11 nines durability as S3, it's extremely cost effective. It was designed in order to provide cost envelope that competes with tape. So as I mentioned, there's the whole family of products when you look at S3 and when you look at Glacier, right? So we have 3 different S3 products. S3 Standard, which is located in multiple availability zones and multiple copies, which are kept in sync. We have S3 infrequent access. So this is ideal for the data that you still want to access within a second that you need it, but you're not going to be accessing it very frequently. So you don't want to store it in the Glacier because you can't wait for the retrieval time, but you still have a use for it. And then finally, the latest offering we announced within the last year is S3 single zone or one zone infrequent access. It's for the data that does not require durability of, I shouldn't say durability, availability of the S3 standard or S3 infrequent access. So you're able to store it at a lower cost than you would otherwise. And obviously Glacier, as you can see, all of these offerings, except one zone, as the name implies, are durably stored across multiple data centers and availability zones. Block storage. So for people who in the room who are, come from a storage background, the easiest way to describe Elastic Block Store is it's your fan disk within AWS. It behaves differently. If you look inside the operating system, it'll look like a locally attached disk. But what I mean by a fan disk is you're able to attach it and then detach it and then maybe attach it to a different instance in the cloud in a persistent manner. It's also very reliable. It's redundant. And finally, it's performant. There are 4 different families of EBS, depending on your use case, and you're able to choose which one of those is the most suitable for the data that you're storing there. And finally, the Elastic File System. And the way you can look at the Elastic File System is like it's like your NAS, right? So network attached storage. You access it either through, this one you access through NFS protocol. It's simple, it's elastic. One thing I should mention about S3 that also applies to Glacier and EFS is that you only pay for the data that you store in this service. So you don't have to allocate anything. For all intents and purposes, they're infinitely scalable, and you only pay for the actual usable capacity, unlike block storage, which is allocated capacity. So having storage is great. You need it. But it's not so much having the ability to store data somewhere. It's the ability to do something with that data. So today, in today's session, we'll primarily focus on the data movement, meaning the storage gateway family, as well as one of our storage partners that D2L is using in their journey to the cloud. But there are a lot of other things you're able to do with the storage. So for example, on a security and management, I'm just going to quickly talk about a service that is not here, Athena as an example, that you're able to analyze and run SQL queries into that S3 bucket without ever moving that data out of it. So basically, as you're building your data lakes and your storage is growing, the challenge becomes moving around different instances. Now you don't. Now you bring compute to that storage. So how do we make storage hybrid? The easiest way to do that, there are a number of different ways, is through gateways. So when we introduced Storage Gateway back in 2012, we were looking at what type of data consumers would be able to leverage this service. And obviously, in the data center and outside the data center, there are many different ways of creating data. And one thing we saw is that although S3 storage is ubiquitous and easy to use, and you can access it from anywhere, a lot of traditional applications were just not made for API calls. They were expecting your SCSI protocol, or your NFS, or your SMB. They were just not able to speak directly to S3. So we created a gateway which would bridge that divide. Initially, people were looking at the gateway for primarily these 3 purposes, right? How do I back up my data into the cloud? How do I make a cost-effective, easy-to-create DR scenarios? Or how do I just park my data into an archive and not have to keep buying storage arrays on-prem? Very quickly, those use cases have expanded, right? Now a lot of people are using our higher-level AI ML services in order to leverage the data they've been keeping, or Amazon EMR, which is our Hadoop service, Athena I touched on, and so on. So now people are realizing that what I can do is I can take the data I'm creating on-prem. I do not have these higher-level services available to me on-prem. I can in an effective and efficient way, move the data into the cloud, and then use these cloud services in order to do something with that data, right? So in the Amazon Storage Gateway family, there are three, so to speak, flavors of the Storage Gateway. We have our Fowler Gateway, which is NFS SMB. We have volumes, which basically we use iSCSI to attach to the on-prem servers. And as well for people who are using backup software and they're still writing their data to tape, or they have a large silo of tapes on site, there's a VTL gateway. And the way it works is that the gateway, which is either a virtual appliance on Hyper-V or VMware, or it can also reside on our Amazon EC2. And actually, very recently, we announced hardware appliance, which is right now only available in US, but we're looking at other geographies if possible. So basically, you have this appliance sitting on your on-prem, and that appliance is talking directly to a storage gateway service in the cloud. And then that storage gateway service is managing the data and putting it into S3 or creating snapshots or placing in the Glacier. And another thing to mention is the most common use cases for storage gateway. And our customers are able to find new use cases every day. But the most common ones are, as I mentioned earlier, people are looking to leverage S3 or Glacier, but their applications don't speak to it natively. So for that protocol conversion. The second reason is people are trying to reduce the on-prem storage and only keep the active data set on-prem and put the rest of it in the cloud. They still want it to be available to bring it back if need be, but they're able to reduce the amount on-prem footprint. And finally, they're looking to how do we optimize the data transfer into the cloud? I can go in and I can use my API commands to move data from on-prem to the S3, or I could use Storage Gateway, which is optimized in terms of compression and sub-file data transfer into the cloud and make this more efficient. So as I mentioned, there's three families which we'll talk right now. So let's start with the Fowler Gateway. This is the latest offering from AWS in terms of a storage gateway family. The way it works is the application server on the left is accessing the storage gateway appliance either through the NFS protocol or recently announced in June, the SMB version 2 or version 3 protocol. If you've heard the term CIFS before, CIFS is just an older version of an SMB protocol for all intents and purposes. So regardless if your server is a Unix, Linux, or Windows, you're able to speak its native language to the storage gateway appliance. Then the gateway appliance directly attaches to your S3 bucket in the cloud. And why this is very important is that it gives you, and I'll talk about it a bit more depth in a second, one-to-one mapping between your objects and what's in the cloud. So if you look at your file server and you look at any of the directories and files in it, and then you look into the S3 afterwards, you will see a correlation one-to-one. Each one of those files you're able to identify in the S3. So as I mentioned, on the right-hand side, we have a bucket here named bucket1. And on the left-hand side, we have the SMB file share. And depending on the folder that you're holding in that SMB file share, we will store those files natively into S3. Either if it's a Windows or Linux, it'll be very, very simple to find what they are and use them for your purposes. So how does it work? I mentioned that you're going to be creating a file share, presenting it to the NFS an SMB client. And on the back end, I mentioned that we're going to have the S3 bucket. That S3 bucket is, for all intents and purposes, infinite. There's no need to pre-allocate storage. The only thing you have to yourself have on-prem is storage for cache. The size of that storage can vary, right? Depends on how active your data set is. Obviously, more cache you have, more data you're keeping on-prem, faster the access is if you're accessing that data, right? So the data cache is not done through a FIFO method, first in, first out, but actually we're keeping all of the hot data in that cache. And we're trying to keep it 100% busy. There's no reason to keep it empty for any reason until you start asking for data that might not be in the cache at that time. So in this case, you're reading the data, you're accessing your cache, and you're getting a response from the on-prem. So basically, you're getting local type latency. In case that data is not in the cache, the appliance itself will reach out to the service, it'll go to the bucket, and it will get, and if you noticed what ranged get really hints at is that we don't have to store a full file in that cache. It can be just a part of the file that's constantly being accessed. In case you're accessing other parts of the file, we go and get them at that time. If you're streaming a movie, we have heuristics enabled. They will proactively go and pull that file ahead of time or parts of that file ahead, so it doesn't wait until you ask for it specifically. OK, that's reading. How do I write to it? So 100% of writes are written to cache. They're synchronously done so. So basically, the moment you write a file to the cache, it's being acknowledged. And then it's asynchronously, but through a multi-part put, which just means to you guys, it's increasing the performance to the S3 bucket, uploaded into the cloud in the asynchronous fashion. So your application will not notice the latency of the cloud if this is how you're leveraging it. But the question is, how do I know my actual data is in the cloud? As you mentioned, it's moved there asynchronously, right? And I also mentioned to you guys that more and more customers right now are looking at this solution in order to use these other AWS services to act upon that data. So if that data is not in there, how do I know it got there? So we introduced recently a Notify on Upload API, which basically what it does is when the file is asynchronously written into that S3 bucket, the Notify when Upload API notifies the Amazon CloudWatch events. And what CloudWatch service is, if you're not familiar, it is just a management service that monitors your environment. Once you get the notification, now you're able to use all of these other services in order to get the value of your data. Metadata cache, as the name implies, stores the metadata from that S3 bucket. So when you're either doing a dir command or ls command on that storage gateway, you're just getting the data from that metadata cache. If there is data that it's not familiar with, or the directory that's not familiar with that you're looking for, it'll go to the S3 bucket. But what happens if you have multiple writers? So we don't recommend multiple writers, but what we do recommend is a scenario where you have a distributed environment. You have one writer, but you have multiple readers around the country, right, which are interested in what's in that bucket. Obviously, they will not know what the writer wrote until they have a way of being notified. So I mentioned before, we have a Notify on Upload API. Another thing we have is a Refresh Cache API, where the Notify on Write API can trigger the refresh cache in all of the other readers, and they will always have a current view of the data in that bucket. So I will quickly just demonstrate a very typical use case we're seeing our customers use this service for. Perfect. Thanks, guys. The first thing I'll show you is, if you remember me talking to you, there's really no reason to pre-allocate your storage. Here I have a Windows server that has a SQL Server loaded on it, and I have mounted the SMB share from my storage gateway. If I look inside that share, into the properties, to look at the size, because I told you that it's infinite, you'll see that I lied to you. Basically, it states that there's 8 exabytes. But this is just because the Microsoft is unable to show you more at this time. But if you keep writing to it, we will keep accepting the data. I'm not sure how the OS will work, because I have not tried to write more than 8 exabytes in the system yet. But if any of you guys have more than 8 exabytes you want to write, let the sales team know. They'll be more than happy to talk to you. Another thing I wanted to show you is that S3 bucket that is backing that share. And actually, let me just go into that file share. I stored a file earlier. It's there. And there is that file showing up in that bucket. Furthermore, I'll just quickly show you the gateway. I have the Fowler Gateway configured. It's telling me that there'll be a software new release coming on November 1st, which at that time, after this time has passed, I'll be either able to upgrade my gateway immediately by clicking on in the console saying upgrade now, or I'll do so at the next maintenance window. And very quickly, here's the actual file share that I've presented to that server. So for the DBAs in the room, this will look very, very familiar to them. Basically, I have AdventureWorks database on the SQL Server, and I'll go ahead and back it up as the DBA would do through a native tool like the SQL Server agent, right? But before I do that, I just wanted to quickly show you what I'm doing. So basically, there's 2 steps in here. The first one, I back up the file. And in the second one, it notifies me that that file has actually been successfully uploaded in S3. So live demos, crossing fingers. Start job. Start. So first green check mark, good. And a second green check mark should be happening relatively quickly. Good, didn't jinx it. So if I go into my file share locally, I will see that I now have 2 files, 2 backups, right? And if I go now into the my S3 management console and I refresh it, I see there it is, right? So although my application, SQL Server, has absolutely no idea that the cloud even exists, it's just doing what it usually does, I'm able to store this backup durably into the cloud, right? But as everyone knows, it's not can you back it up, but can you restore it, right? Anyone can back it up. Just if you can't restore it, it's pretty fruitless. So in order to restore it, still use a native SQL tools. Go to the device. I just realized that I go to my file share. Control-C. Being able to see this. It's a different. Oh, there it is. Doing it live. All right. I'll remove this. I'm going to add this. And that's what I was expecting to see. So I'll take my file. I'll run the restore. I can see when the file was backed up. Now I restored it over top of each other, over top of itself in case it was corrupted. I could also restore it as a different name, which would show up under SQL Server as a different database. So going back to the presentation. So what did we learn through this? We're learning that we are able to leverage a Fowler Gateway on-prem with the application which do not speak to the cloud. We also learned that as those files are being written to the storage gateway, they're also showing up in S3. And we're also finding the way that if something was to happen to the site where the server was stored, I would have been able to restore that data not just to the same server, I was able to restore it into any site for DR purposes perhaps. So, and that was my diagram. So, how do we now, that's file storage. How do we behave with block storage? Well, we have volume gateways, and what they do is they present their volumes not as file shares, but they present themselves as iSCSI mounts, right? So we're able to access the volumes they're presenting as an iSCSI. They, in turn, talk to the storage gateway service, and as I mentioned earlier, by communicating with the service at first, they're able to play games. They're able to compress the data. They're able to store it in a more efficient manner, and it reduces the cost to the customers. The fact that they're storing block data into the S3 bucket, and the fact they're compressing it and playing games also means that the value of seeing this bucket in the cloud is nil. It would show no benefit to our customers, so that bucket is actually being managed by the service itself. The only thing the customers see is when you're creating the restore points through a snapshot mechanism is the EBS snapshots which are kept in AWS. So we have two different types of volume gateways. The first one that came in the market, so this is the original storage gateway back in 2012, is a stored volume. What this means is that 100% of your data, if you remember what I mentioned before with the Fowler Gateway, you have a cache drives, that's all you have to commit on your end beyond the infrastructure to host the appliance VM. Here it's different. Whatever amount of storage you want to access, you require that much amount of storage on-prem. Why do I want that? Well, for two reasons. One, you know that regardless of what your data set is, you're going to have a local speed and local latency performance. Okay, so what's the point of putting it in AWS? By creating snapshots in this mode, you're able to have, which I'll talk a bit into more depth later on, the data in the cloud that you can use for either DR, bring it back to the same site, or even maybe bring it up your DR site, not just at a secondary site, which you can, but also in AWS Cloud if you're just doing it for testing purposes or you're looking to move there. The second type of volume gateway we have is a cached mode. So this is much more similar to the Fowler Gateway from a perspective that, again, all you have to commit is that cache drives, and then you're able to have not the unlimited amount per gateway, because each cache mode gateway can support only 1 petabyte of storage. But if you put multiple gateways, again, you can have more storage. The good news here is that, as I mentioned before, is for investing a couple of hundred gigs on-prem, you're able to store up to a petabyte of data into the cloud. So let's talk about the DR use case. So there's two different ways you can do that. One is by leveraging EBS snapshots, which, as the name implies, is a point-in-time replica of your data, or through doing volume clones. Volume clones are real-time, whatever state of your S3 bucket at that time is, we're creating the exact replica of it. And then you're able to use it for testing, DR purposes, and number of different needs. So in this case, where these snapshots are being taken from is not necessarily from the gateway appliance itself. You're taking it from that bucket, which is stored in S3. It's important if you're dealing with data that requires application consistency to ensure that the data has stopped writing before creating those snapshots to keep them consistent. Once you have them, as I mentioned, we see people doing it for three things. One, my drive has failed or my storage array has failed. I need the data back. Two, I need either to spin up instances in AWS for testing purposes or for migration purposes. Or three, I have my disaster recovery site. I just didn't want to keep all the data stored there just in case, because I might have 50 of these different data centers, and I'm only going to push it once disaster has occurred. One of the things I should have mentioned about stored mode is that it works ideally for migration. Why? For all the other ones, we expect data to be brand new, so drives to be clean with no data on them. With the store mode, you're able to put your existing drives with data in it we will import it into the storage gateway appliance, and in the background, we'll start moving it into the cloud. So that's one of the advantages of a store mode, that's cache mode, of the store mode appliance, that people are also using it for migration purposes. One of the customers, actually this customer has been using storage gateway appliances for the last 5.5 years. Stemcell Technologies, they're the largest biotech in Canada. They're based out of Vancouver. They have 1,100 employees. They're growing at 20% a year. They're doing really, really well. Along the way, they realized that doing IT is not their core competence or something they shouldn't be doing. So they were looking for a way to, but don't forget, these guys are generating a lot of data on-prem. They can't just go all into the cloud. So we're looking at a way they can still talk to both their legacy applications, but also potentially devices which do not speak cloud, microscopes or things of that nature, and move the data into the cloud. So in 2013, they started evaluating storage gateway. They were using it in dev test, and in 2015, they moved into production. Currently, 45% of their environment is in AWS, 40 is leveraging SaaS services, and only 15 are on-prem. Their goal within the next 12 months is to move so 5% is left on-prem. So how do we deal with the scenarios where you're still leveraging your backup software and still writing to tapes, or you've been writing tapes for years and you have compliance requirements where you have to keep it for the next 7 years or next 20 years? For that purpose, we created a AWS tape gateway, the VTL tape gateway, which presents itself not as an iSCSI mount and not as the file share, but actually as the tape changer, right? So robotics in the library and tape drives. You're able to put up to 1,500 tapes or up to 1 petabyte inside the quote unquote the virtual library. But what we have also done here is we have integrated it with the Glacier service. So just like what you were doing today, where you eject the tapes and then have a tape service take them away to an external site, you're able to eject these tapes into the Glacier and keep them there indefinitely, and there's no capacity limitations from that perspective. Looking at the way that the cost of managing the backup environment, it's not so much in tape library. It's not so much in tapes themselves. It's everything else. It's the people, it's the process, it's the offsite archival service, and we find that with the VTL tape gateway, we're seeing a lot of customers moving for that purpose. So as I mentioned, the actual library itself presents tape drives and media changers. It doesn't really present tapes. Tapes are kept in the S3 bucket in AWS. And you also require the both cache and the upload buffer. Upload buffer is used for optimization of movement of data into the cloud. So as I mentioned before, we have customers with a lot of offsite data or onsite data they're looking to get rid of. And by introducing the tape gateway, they're able to use the native tools and write, maybe do a copy job or use the same policies you used before for moving that data into AWS. So what do we learn? So first of all, by using storage gateways, you're able to reduce your on-premise footprint to just focus on the data that you're actually using. You're also able to move data more efficiently and more effectively into the cloud. And finally, as I mentioned earlier, people are able to leverage this technology for not just DR or backup or moving to the cloud, but also a hybrid scenario where they're leveraging other AWS services. Now I'd like to invite Matt Campbell from D2L to tell us how D2L is using hybrid storage in their move to the cloud. Thanks, Matt. Thanks.
Thank you, Stefan. So yeah, I work for D2L. My name is Matt Campbell. I'm an engineering director there. And the team that I work with, we're currently responsible for moving our flagship product into AWS. So we're going to go full all in AWS. And what is that product? Well, we build learning management software. So if you were a student at some point, that's pretty cool. Being a student's good. Well, we build the software that your professor would have put your notes into, where you could access them afterwards, have a discussion with your classmates, panic at the last minute and try to get your submission in before the deadline, that kind of stuff. We are a global company, so AWS does benefit us a lot in the fact that they do have that global footprint, and that we also do have those data sovereignty issues that Steven mentioned with the biotech company, and that we need to keep our data in the residence of that client. We are also kind of large, so that also meant we have some problems with trying to do our migration, and that we have to maintain the support that our customers want as we're moving forward. Now, I want to talk to you about the storage part, as that's what this talk is about. And we had two main problems to solve. We were trying to migrate our clients from self-hosting, so we have our own colo facilities where we host clients, into the cloud. But at the same time, we also wanted to optimize how our application worked to really take advantage of what AWS offers. I'm going to focus mostly on the storage part, but just quickly on the migrating part. We do use NetApp, so we were able to leverage the NetApp SnapMirror technology to actually move our data from the colo facilities into AWS, backed by EBS on NetApp ONTAP in the cloud. This allowed us to separate the actual movement of clients into the cloud from the work that the group I work with mostly is doing, which is optimizing how those clients actually work when they get there. The way we move the data with SnapMirror is you can have SnapMirror start to migrate the data in the background for you. So as data is being added in, that data is just slowly being trickled up into the cloud for you. We do have to take a small downtime window. Obviously, we want to make sure we get all of the client's data, and we don't want to miss anything during that final cutover. But because of that technology, we were able to help minimize the amount of time our clients went down for as we were doing that final lift up into AWS. Regarding the storage optimization, there was quite a lot more work to do there. We've been around for about 15 years, and if you've worked at a company that's been around for longer than 5 minutes, you realize your code gets old very quickly, and you look at it 5 minutes after you wrote it and go, who could have written this code? And then you do a blame and you realize it was you. We had a lot of refactoring to do. None of it was my fault, of course. And that meant that we had to, before we could even put a single file into S3, we really need to revisit how our application accessed storage. And it turned out over the years, we got lazy with the fact we were using block-level storage, and we allowed the application to know it was using block-level storage in more than one spot. So we sort of violated those multi-level app principles, which meant we had to start there by reducing the amount of knowledge the code base had, reducing the spaghettiness of it, and filtering it down so that there was a single entry point between the application and the storage layer. No, that's the wrong button. Once we did that, and we now had a single way to talk from the application to the storage layer, we were able to start experimenting with that new paradigm that's presented by moving your data into S3 and moving from block-level storage into object storage. Our driving principle in this was to be as invisible as possible to our end users. We ideally want no one to know that we're actually doing this work, which is why I'm standing here talking about it. But we wanted to make sure that they didn't know that we were actually moving their files. That's something that the client shouldn't really care about. They want to access their files. They want them to appear when they click on the link. So in order to move the files and to experiment with how object storage work while also maintaining high levels of availability, we actually built an in-application service. This ran in the background of our main application and slowly started to trickle files into S3 for us. We also then, using feature flags, we could control where we chose to read the files from. So we could read them either from the NetApp system we had on the cloud with NetApp ONTAP, or by flagging it on, we could choose to pull those files from S3 instead. This allowed us to selectively decide which files we were going to let the client pull from S3, and then also gave us that quick escape cord to pull if things went south. This also had another advantage to us in that we could then quietly start to gather data on how this system worked and make sure when we did all that refactoring, you know, if you've done a major refactoring before, you always miss something. We wanted to make sure that when we actually went fully live with this, that we had caught everything. So as an example here, one of the kinds of files we store is a profile image. So when you log into our system, you can set up your profile. You can upload a picture of yourself so all the other students and teachers know what you look like. The nice thing about profile images is they load on almost every page in our system, but if they fail to load, the application still works fine. So they were the perfect guinea pig for us to test out that this migration actually worked properly. And here's some of that data we were pulling in the background as we were running this application in dual mode with files both in NetApp and S3 and selectively reading from S3 when we felt brave enough. We actually managed to move over 300,000 profile images. Now, of course, profile images aren't huge, but that's quite a large number of files. We migrated that from our NetApp cluster into S3 in just under 3 hours, and then we're able to turn that on to start doing the reads from that, and that gave us a huge amount of data across our system to validate that our refactoring had worked properly. Once we gained confidence with that, we slowly started to migrate more and more file types, and then more and more files as well as we moved our way through. So that's a quick summary of almost 2 years worth of work at this point, which sounds way quicker than the pain we went through to do it. But I would say that if you're looking at doing this work, key things are is you want to start small, pick something that's easy, minimize your blast radius as you do it, but then actually just go ahead and start doing it. Find some people in your company. You probably have people who already kind of know a lot about the storage. Give them some space to work, and then let them go at it. Thank you.
So just to close off, Matt and I will be sticking around in the back after the session for any questions. We are pretty much out of time right now. And please don't forget to rate the session positive or negative. We're very much a data-oriented company. We always look for feedback in a way we could improve for the following summits to come. So thank you very much for spending an hour with us, and hopefully you enjoy the rest of the day. Thanks, guys.